A NASA insider claims that the Voyager 1 has just detected a massive inject traveling through space. The Voyager probes, which have been exploring the solar system for almost 40 years, have now arrived at the region of deep space that has not been studied before. After making contact with a mysterious being, the Voyager 1 spacecraft has piqued the interest of scientists who are eager to discover more about the mystery that surrounds these incredible events. An instrument has only recently detected what appears to be an unanticipated shift in the magnetic field that surrounds the spacecraft. This change is indicative of the presence of a magnetic effect, because the magnitude and length of the disruption were unlike anything they had ever experienced before. NASA scientists began to rethink their initial theory, which suggested that a cosmic ray or high-energy particle going across space would be the cause. Well, Voyager 1 just detected a massive object traveling through space. The magnetic field that encircled Voyager 1 appeared to be subject to the effect of an unknown source, which was causing it to fluctuate in a manner that NASA experts were unable to comprehend. It almost gave the impression that the spaceship had collided with a barrier that couldn't be seen. The scientists at NASA are continually investigating this enigmatic energy in an effort to better understand it. They are investigating a broad variety of potential outcomes, such as the existence of intelligent alien life and peculiar astrophysical occurrences. A number of people have put up the hypothesis that the disturbance was caused by dark matter. The sudden and unanticipated shift that was detected by the spacecraft in the magnetic field is suggestive of the possibility that the source of the disturbance is an unknown external influence. Voyager the 1st of May have come into touch with a cosmic ray of unknown origin, which may be one of the possible explanations for the unexplained power. It is believed that these high-energy particles originate from a location that is not inside our solar system, since they have the capacity to affect the behavior of charged particles that are found in the heliosphere. A coronal mass ejection is another notion that has been put forward to explain the disturbance. This is a significant solar plasma outburst that has the potential to create issues in the medium between the planets. Voyager 1 discovered a disruption that was both extensive and long-lasting, which leads one to believe that the origin of the mysterious energy may be more problematic than was initially believed. It began its imaging mission of Jupiter in April 1978, when it was approximately 165 million miles, or 265 million kilometers, from the planet. When compared to how it appeared in photographs that were returned by January 1979, Jupiter's atmosphere appeared to be more turbulent than it had been during the Pioneer flybys in 1973 to 1974. On January 30, 1979, the Voyager 1 spacecraft began snapping photographs, and it continued to do so at an interval of 96 seconds for a total of 100 hours. A color time-lapse movie was produced as a result of this, and it displayed 10 revolutions of Jupiter. On February 10, 1979, the spacecraft made its way into the Jovian moon system, and a few weeks later, in early March, it discovered a ring that was less than 30 kilometers or 19 miles thick and that encircled Jupiter. 5 new moons, a ring system with thousands of bands, wedge-shaped transient clouds of minute particles in the B ring that were dubbed spokes, a new ring, the G ring, and shepherding satellites on either side of the F ring that maintain the ring's sharp edges were discovered by the Voyager 1 spacecraft. During its flyby over Saturn, the spacecraft took pictures of the moons, Titan, Mimas, Enceladus, Tethys, and Rhea. The evidence that was pouring in revealed that the primary composition of all of the moons was water ice. Following the impact with Saturn, Voyager 1 embarked on a trajectory that would take it out of the solar system. This path took it at a speed of around 3.5 AU per year, 35 degrees to the north of the ecliptic plane, and roughly in the direction of the Sun's motion with regard to neighboring stars. Voyager 1 has now successfully escaped the solar system. Because of the specific requirements of the flyby of Titan, the spacecraft was not aimed in the direction of Uranus or Neptune. On February 14, 1990, the cameras aboard Voyager 1 were turned around so that they were pointing in the other direction. During this time, some 60 photographs of the Sun and planets were taken, creating the first portrait of our solar system as seen from beyond it. These photographs were taken at a distance of 40 AU from the Sun, which is equivalent to 3.7 billion miles or 6 billion AU. The overarching goal of the new mission is to broaden the scope of NASA's investigation of the solar system beyond the region around the solar system's outer planets, all the way to the edge of the Sun's sphere of influence, and maybe even farther. Collecting information on the boundary between the heliosphere and the interstellar medium is one of the specific goals of this mission. A gold-plated copper disc with a diameter of 12 inches, 30 centimeters, and made by a team directed by Carl Sagan, serves as the message that is delivered by each Voyager to any prospective extraterrestrials that may come across the spacecraft. The record, much like the plaques that can be found on Pioneers 10 and 11, has symbols that indicate the location of the Earth in respect to a number of pulsars. The records come with instructions on how to play them using a cartridge and a needle, just like a vinyl record player would include instructions on how to play the records. There are greetings in 55 various languages, 35 noises from the Earth, such as whale calls and laughing, and 90 minutes of music that is largely Western in origin, ranging from Mozart and Bach to Chuck Berry and Blind Willie Johnson. In addition to this, there are 115 photographs of life on Earth, as well as greetings from former United Nations Secretary-General Kurt Waldheim, 1918 to 2007, and former President of the United States Jimmy Carter, 1924 to present. The Voyagers are currently around 11 billion miles, 18 billion kilometers, distant from the Sun, which means they no longer feel its warmth. In 2019, the engineers working on the mission started implementing a new management plan for the older robots in order to ensure that they continue to provide the highest quality scientific data they are capable of. In particular, with relation to the spacecraft's sensors and thrusters, coming to judgments that are challenging to make is a component of the plan. Voyager 1 was successful in all aspects of its mission in relation to Jupiter, with the lone exception of the tests that utilized its photopolarimeter. Scientists were forced to re-examine previous atmospheric models because of the revelation that Jupiter's atmosphere was more active than it had been during the missions of Pioneer 10 and 11. These models were unable to account for the unique phenomena that were seen. The spacecraft was able to look at the moons, Amalthea, Io, Europa, Ganymede, and Callisto, which allowed for the very first time for the surface characteristics of those moons to be examined. In August of 2012, the Voyager 1 spacecraft made history by becoming the first to go into interstellar space. If we consider anything that primarily circles the Sun to be a part of our solar system together with the Sun itself, then it will remain a part of our solar system until it exits the Oort cloud sometime between 14,000 and 28,000 years from now. The Voyagers are still delivering communications from outside the heliosphere, but at this point, the only information they can supply is about the circumstances in their immediate vicinity. Scientists have figured out how to map some of the broad contours of the heliopause by keeping an eye out for emissions from energetic neutral atoms, ENAs. These emissions are formed by interactions between the solar wind and the interstellar wind. Even though a large portion of this transitional area is still unknown, scientists have learned how to map some of the heliopause's broad features. Do not forget to sign up for more up-to-date space content. Recent research conducted in the month of October 2022 by scientists has shown that at the boundary between our solar system and the vast expanse of interstellar space that lies beyond it, they discovered odd structures and ripples. The research results show that the protective heliosphere around the solar system, also known as the heliosphere, fluctuates in ways that are intriguing and potentially controversial, as the report acknowledges. The heliosphere extends out into space for approximately 11 billion miles, which is more than twice as far as the distance that Pluto travels in its orbit. The heliosphere is formed by the solar wind, which is a flow of charged particles that is expelled by the Sun. The boundary of this structure is denoted by the heliopause, which is the region where the pressures of the interstellar medium prevail over those of the solar wind. The Voyager 1 and 2 spacecraft, both of which were launched by NASA in 1977, have both surpassed this barrier within the past 10 years, making them the first relics constructed by humans to go into interstellar space. Researchers just detected a new discovery 4 minutes ago. Check next post to find out.